Hi, my name's Bill McKibben. I teach at Middlebury College in Vermont. Way back in 1989, I wrote what's usually called the first book for a general audience on global warming, a book which came out in a bunch of languages and was serialized in the New Yorker magazine. The robust public debate on climate science only goes back about that far, less than 30 years. So I'm here today with a few friends to try and bring you up to date on climate science, climate solutions, really where we stand right now. I'm joined by Mustafa Ali, until recently the longtime head of the environmental justice programs at the Environmental Protection Agency, by the actor and activist Maggie Gyllenhaal, Catherine Hayhoe, who runs the Climate Science Center at Texas Tech, and by the planet's preeminent climate scientist, James Hansen, who was in charge of NASA's Earth Science program for many, many years. I said a minute ago that society's only focused on the threat of global warming for about 30 years. But scientists began to focus on the question long before that, really as far back as the 1820s, when the French scientist Jean-Baptiste Joseph Fourier realized that given its distance from the sun, the Earth should be much cooler than it actually is. In fact, the average surface temperature, all else being equal, should be right around 0 degrees Fahrenheit, much like the moon. He theorized that something in the Earth's atmosphere must be acting as an insulating layer and trapping some of the sun's heat here on Earth.
It was a pioneering female scientist, Eunice Foote, who was among the first to realize that carbon dioxide was a key part of that insulating layer. In the early 1850s, she pumped the air out of a glass tube and filled it with CO2, using a thermometer to show that the sun's rays heated it more than they did regular air. Her paper concluded that, quote, an atmosphere of that gas would give our Earth a high temperature. The work was duplicated and extended 3 years later by the famous scientist and mountaineer John Tyndall. It's just possibly possible that one reason we remember him and not her is because he was a man.
In any event, another 50 years passed, and the great Swedish chemist Svante Arrhenius, who would later win the Nobel Prize, pointed out that because we had begun to burn coal to power our industry and heat our homes, it stood to reason that eventually the amount of CO2 in the atmosphere would increase enough to heat the planet. That's because when you burn coal or oil or gas, you give off CO2, and quite a bit, actually. A gallon of gas weighs about 6 pounds, and since it's 87% carbon, it gives off about 5.5 pounds of carbon when you burn it. Each carbon atom combines with 2 oxygen atoms from the atmosphere, CO2, remember, so that the 6-pound gallon of gasoline actually produces about 20 pounds of CO2 when it burns.
Anyway, Arrhenius's calculations were mostly ignored for the first half of the 20th century. Most people who thought about the question at all concluded that the vast oceans would soak up any extra CO2 that humans emitted, so no problem. But in the 1950s, a pair of ocean scientists, Roger Revelle, Hans Suess, figured out that the upper layers of the ocean were actually pretty well saturated with CO2. So they guessed it must be accumulating in the atmosphere instead. They found a young scientist, Charles Keeling, to test the hypothesis. He built a small CO2 monitoring station in a hut on the side of the Mauna Loa volcano in Hawaii. He turned on the instrument in 1959. Within a year, it was clear that, indeed, the amount of carbon dioxide in the atmosphere was increasing. It's gone up every year since. This graph, the Keeling curve, is one of the most famous charts in all of science. The annual wiggle is because when spring comes to the northern hemisphere, the plants soak up a lot of CO2, and then when they die in the fall, they give it off. But every year, the curve keeps going higher because we keep burning coal and gas and oil. We still didn't know, however, how much CO2 was too much CO2, where the danger line lay precisely. Climate's what scientists call a noisy system. The temperature goes up and down from year to year and place to place. They needed more computing power to be able to figure out exactly where the danger zone lay.
Some of the first scientists to conclude that we were beginning a dangerous heating of the Earth worked for the biggest oil companies. In July of 1977, Exxon's chief scientist told the company's top management team that there is general scientific agreement that burning fossil fuels was warming the climate. A year later, in 1978, the executive of the world's largest oil company got a more explicit warning. Doubling the amount of carbon in an atmosphere would raise the temperature 4 to 5 degrees Fahrenheit. They believed him and began doing things like building drilling rigs to accommodate the sea level rise they knew would follow, but they didn't tell the rest of us.
Instead, it took someone else to issue the public warning, and that someone else was Jim Hansen, who we've met already. By 1988, he was ready to tell a congressional committee the bad news. Jim, can you recall that moment for us?
Yeah, well, the story became pretty clear during the 1980s because we had been doing modeling for a number of years and realized that the planet was really warming and it was consistent with what we were calculating in the climate model. And by 1988, we had a paper accepted for publication in Journal of Geophysical Research. So I thought it was possible to make a pretty strong statement. And because the weather was so hot at that time, the statement got a lot of attention.
Since then, the news has grown steadily worse as climate change and its effects have come far more rapidly than we hoped. The rise in temperatures has been remarkable. 2014 was the hottest year ever recorded on our planet until 2015 smashed that record, until 2016 smashed that record. We've seen the same kind of anomalies in the US. This past February, for instance, we had 29 new all-time low temperature records in the US and 4,498 new high temperature records. Last summer, we saw the highest reliably recorded temperatures ever observed on Earth, about 130 degrees, in the city of Basra, Iraq, and the surrounding countryside. This is at the upper limits of human survival.
The extra warmth that our CO2 traps is the heat equivalent of about 400,000 Hiroshima-sized nuclear bombs every day. That's enough heat energy to have melted at least half of the meters-thick, millennial-old ice that once covered the Arctic. You can see how fast it's falling right through 2016. It's enough heat to have destabilized the vast glaciers and ice sheets of the Antarctic. It's now bleached huge swaths of the world's coral reefs. The level of the world's oceans has begun to rise. Here's something important to remember. Warm air holds more water vapor than cold. That means we get more drought in arid areas and more downpour in wet areas. Where I live, in the northeast United States, the number of huge downpour rainstorms has increased more than 70%.
Sea level rise is, in my opinion, the biggest issue because it has the potential to hand young people a climate system that's out of their control. If the ocean warms enough that it's going to melt the ice shelves, the tongues of ice that come out from Greenland and Antarctica into the ocean, then it could lock in sea level rise of several meters. That would mean we would lose all coastal cities on a time scale that's difficult to predict, but could be as soon as 50 years and is unlikely to be more than 150 years if we continue to emit greenhouse gases rapidly. And the moving of people away from the shore is going to dwarf what we've seen in recent years. It may, frankly, make the planet ungovernable.
All these enormous effects are happening in the early stages of global warming. So far, we've increased the planet's temperature barely more than 1 degree Celsius. But remember that even Exxon scientists warned we face temperature rises 3 times that large or more. That's why even the Pentagon has warned that instability caused by climate change is among their greatest fears.
Sometimes people say, sure, the climate's obviously warming, but maybe this is just a natural cycle. How do we know it's caused by humans? This may be the most common objection to taking climate change seriously, and so it's precisely the one that scientists have studied most carefully. One of those scientists is Katherine Hayhoe at Texas Tech, and she can bring us up to date on the latest answers.
We know that climate has changed before. It was warmer when there were dinosaurs, it was colder during the Ice Age. So how do we know it's not just a natural cycle this time? To answer that question, we look at all of the different reasons that have caused climate to change in the past. One of the biggest reasons why climate has changed in the past is the sun. Over time, the sun's energy gets brighter, and then it gets a little dimmer. When we get more energy from the sun, we get warmer. When we get less energy from the sun, we get cooler. So, has the sun's energy been going up the last few decades and centuries? Well, over the early 1900s, the sun's energy did go up a little bit. But since the 1970s, it's been going down. So if our temperature were controlled by the sun right now, we'd be getting cooler, not warmer. But what about those natural cycles that we have inside the Earth's climate system, like El Nino, for example? We understand those cycles. Us atmospheric scientists are the ones who study them. And while they still have some mysteries to be uncovered, we understand the basics quite well. And the basics are this: these natural cycles mostly just redistribute heat around the Earth system. They don't create it or destroy it, they just move it around. So one place gets warmer, another place gets cooler. Heat goes from the ocean into the atmosphere and then back from the atmosphere into the ocean. The net effect of natural cycles inside the climate system over the past 100 years or so has been basically null. They can't cause a huge warming or a huge cooling. So only when each of these natural suspects has an alibi can we finally say, could it be something else?
Every scientific body on Earth has said the same thing by now. Global warming is caused by humans, and it's very real. And if for some reason you don't trust scientists, then ask the insurance industry, which is the part of our economy in charge of analyzing risk. As the world's largest insurance company said, quote, "The only plausible explanation for the rise in weather-related catastrophes is global warming."
So, climate change, to sum up, is the result of fairly simple physics, as scientists first started to realize more than 200 years ago. The molecular structure of CO2 traps heat near the planet that would otherwise radiate back out to space. That's it. Because their warnings have been largely ignored by politicians, scientists have become increasingly active in the fight for solutions. We'll talk more about those solutions in the next video.